and see if we find some new mechanism based on the laboratory measurement and also the field measurement, we can implement this new theory into the global model to see if they have this new phenomenon, how will impact global climate change. So my lab, we try to understand the aerosol and cloud interaction and their feedback to the climate change. We do the field measurement in different locations. For example, I have been to the Arctic and Africa. We try to figure out the marine aerosol and also the dust, in which kind of way they can serve as cloud-causing nuclei to form the cloud, how it impact the local climate and also the climate in the global scale. The aerosol can affect the climate in different ways. For example, the aerosol can, some of the aerosol like black carbon or brown carbon, they can absorb the light. Basically, this is warming, and some of the aerosol can...
Aerosols are small particles.
Yes, small particles, and some of the aerosol, for example, the dust, the organic aerosol, ammonium sulfate, these aerosols, they can scatter the sunlight. So the aerosol itself can absorb the sunlight or scatter sunlight. Basically, they can affect the climate. And this is called aerosol direct effect. The aerosol indirect effect refers to the aerosol can active to the cloud droplet under certain surface aeration. Once you have the cloud, and the cloud can reflect the sunlight. Once you have more aerosol to active as a cloud, basically you will have a thicker cloud. Basically, you increase the cloud albedo. This is referred to the aerosol indirect effect. And also, more aerosol add to the cloud. You have a smaller cloud droplet. It also have a longer lifetime of the cloud. The cloud can survive for a longer time. Basically, also increase the cloud albedo. This is called aerosol indirect effect. So that's why the aerosol and aerosol cloud interaction, they have impact on the climate change. So, and also for the geoengineering, solar geoengineering work, once you emit more aerosol in the stratosphere, you have the aerosol can scatter the sunlight, basically cooling the surface Earth. This is stratosphere aerosol injection. And the second, we call it marine cloud brightening. Basically, we emitted a lot of aerosol in the marine environment. This aerosol can act to a cloud droplet, and you have the cloud cover, and then the cloud also can reflect more sunlight. Then they also cooling the surface of the Earth. So that's why we emitted more aerosol in stratosphere, or we generate a cloud. It can cool in the surface of the Earth.
What are the major risks of this approach?
So one of our research, we were analyzing once the aerosol, you emitted aerosol in the stratosphere and can survive for a longer time and can transport it to the polar regions. But in the polar regions, for example, the Arctic, actually the Arctic temperature warms more faster than the global average. So this phenomenon we call Arctic amplification. But the polar regions are quite special, especially during the winter time, because of winter time you don't have the sunlight. And also once you form the cloud, the surface long-wave radiation will be scattered back to the surface. Basically, this is warming effect for the polar regions during the winter time. So one of our research, we try to analyze once you have more aerosols transported to the central Arctic, basically you're warming the surface of the Arctic during the winter time without the sunlight. Think about that. Once you have a lot of aerosols surviving in the stratosphere and transported to the polar regions, during the winter time you will get a warming polar regions, not a cooling surface. And warming surface in the Arctic will also warming the sea ice, and the sea ice melting, you will have this kind of consequence, like warming the surface in polar regions. So this is the solution have a different effect on the surface temperature at different locations. This might be one of the consequences of the stratospheric intrusion is project. Yeah.